Hi, welcome to the first video of the differential equation class. Okay, so in this first video I'm going to give you very basic definition of the differential equation and some examples and what do we mean by solution of a differential equation, and also we will talk about the order and degree of a differential equation. Okay, all right. So an equation that contains a function and its derivative is called differential equation. So if you see an equation that has a derivative of a function, then that equation is called differential equation. For example, this equation has dy over dx equals to 2y. This is a differential equation. Another equation has dy over dx equals to x over y. Or the third equation has d square y over dx square. This is the second derivative, right? You guys know that from Calc 1 equals to 2 sine y times dy over dx plus cosine of x. Okay, so here we are using the first derivative. Okay, this is the first derivative, this is also the first derivative, this is the second derivative. So this is called first order differential equation and this is called second order differential equation. So if the highest order of derivative is 2, if the second derivative is the highest order of derivative, that is the second order differential equation. Okay, if the highest order is 3, then that will be the third order differential equation, and so on. Okay, all right. So the solution of a differential equation is a function that satisfies the differential equation. Meaning, if any function, if you plug in the value of that function into the differential equation on the left side and right side, if you get the same value after you plugging in, then it is called the solution. Okay, for example, let us consider a differential equation, the first equation here, dy over dx equals to 2y. Okay, this can be written as y prime equals to 2y as well, because this is another notation for the derivative dy over dx, right? So here y equals to e to the 2x is a solution. That's what it says, meaning that y equals to e to the 2x, when plug in here in the equation, you will get same value on the left side and the right side. Let us check. If you find the derivative of y equals 2x, that will be y prime will be, it is like u, right? You need to use the chain rule, right? So e to the u times u prime. So what is the prime of that? That will be 2, right? So the derivative of y equals e to the 2x. So since y equals e to the 2x, y prime equals to 2e to the 2x, right? So let us plug in that on this equation. So you get 2e to the 2x, that is the left side value, or here, right, equals to 2 times the value of y is e to the 2x. So you got the left side and the right side equal, right? Therefore, y equals to e to the 2x is the solution of this differential equation. Okay, hence y equals to e to the 2x is a solution of the differential equation. Okay, let me just write a solution of that, just the solution. Now, how about y equals to 3e to the 2x? Do you think that is also the solution? Let us check. Okay, suppose I want to check whether this y equals to 3e to the 2x is the solution or not. So how do I do that? Let's find out the left side first, dy over dx, or let's find out y prime. What is y prime for y equals 3 to the 2x? 3 is already there. Now you can think this as like e to the u, right? Since this is a constant, you can pull that to the front and then find the derivative of e to the 2x, right? So let me do that, e to the 2x, oh sorry, so e to the 2x in the exponent, e to the 2x, e to the 2x, and then prime. You can do that, right? So what is the derivative of e to the 2x? You can think of this like e to the u. What is the derivative of e to the u? Is e to the u times u prime. So u prime will be just 2. So like 3 times 2 e to the 2x. So that will be 6 e to the 2x. That is the left hand side. And if you plug in that, you will get y prime equals to 2y will be 6 e to the 2x is y prime equals to 2 times 3e to the 2x, that is 2y, because y equals 3 times e to the 2x, right? So you get 6e to the 2x equals to 6e to the 2x. So y equals to 3e to the 2x is also the solution. And if you keep doing that, if you replace 3 by 4, 5, 6, 1, 2, -1, -2 like that, all of them satisfy the differential equation. What can we say about that is, we can say that a differential equation can have more than one solution that satisfy the differential equation. Okay, so a differential equation can have infinitely many solutions. We call family of solutions there. Okay, a differential equation can have family of solutions. All right, let us do another example. Check if y equals to -9 x e to the -3/2 is a solution of 4 times x squared times y double prime second derivative plus 12x y prime plus 3y equals to 0. Let us check that. Okay, so what is y? Y is -9 x to the -3/2. Okay, now let us find out dy over dx, that is basically y prime, right? So how much is that? -9 is there. Okay, and then it is like x to the n, right? What is the derivative of x to the n? It is n x to the n minus 1 power rule, right? So -3/2 x to the -3/2 minus 1. What do you get? You get 27 over 2, right? Times x to the -3/2 minus 1 will be -5/2. So we will plug in that value y prime here later. Okay, let's find out y double prime to plug in here. So let's find out y double prime. Okay, what do you get? If you find out y double prime, you find out the derivative of this guy. So there is 27 over 2 already, and then you do -5 over 2 times x to the -5 over 2 minus 1. Again, n x n minus 1. For the constant, you can pull that out and find the derivative of that only. Okay, n is -5/2 times x to the -5/2 minus 1. What do you get? You get 27 times 5 is how much? Is that 135? So you get -135 over 4, because 2 times 2 is 4, right? X to the -7/2. Okay, so now what we want to do is we want to plug in these values here and then check if you get left side and the right side shape or not. Okay, so let us plug in that. You have 4 times x squared times -135 over 4 times x to the -7/2, right? And then plus 12x times y prime is 27 over 2 x to the -5/2, right? And then plus 3 times y is -9 times x to the -3/2, x to the -3/2 equals to 0. So we want to get the left side and right side both equals 0. So what do you get? If you cancel them out, 4 divided by 4 is 1, right? Let me pick different color. 4 divided by 4 is 1. Also 12 divided by 2 is 6 here, right? So what we want to do is we want to find out, so how about this one? This will look like -135 times there is x squared, there is x to the -7/2. What do you get? X to the 2 minus 7/2, right? Because if you combine that, if you multiply that, you write the same base and then you add the exponent. Plus, what is 6 times 27? So 27 times 3 is 81. So 81 times 2 is 162, right? 162, and then x to the 1 minus 5/2. Because there is x to the 1, there is x to the -5/2. That's why you combine that. And then minus 27 x to the -3/2 equals to 0. We don't know it, whether you get the left side and right side equal, right? So let us simplify this. You get -135 x to the 2 minus 7/2 will be -3/2, because 2 is 4/2 minus 7/2 will be -3/2, right? Plus 162 x to the -3/2, and then minus 27 x to the -3/2 equals to 0. Look at this. All of them have the same, they are the like terms, right? Because all of them have x to the -3/2 in common. So if you take that factor out, what is left is -135 plus 162 minus 27, which is 0. Basically, okay, if you add this guy and that guy, you will get positive 162 x to the -3/2, sorry, negative 162 x to the negative 3 half, and plus that will be 0 equals to 0. So the answer is yes. Okay, so the answer is yes. Yes, this is the solution of this equation. So this is how you check if a function is given, and if you are asked to find out, check if this is a solution or not. Okay, you find out the derivative and then plug it into the derivatives there. All right, guys, thank you.